My name is Melissa Lincheski. I am a professor here at NIU. My home department is the Department of Earth, Atmosphere, and Environment. If you think about your life and plastics, it's everywhere. The plastics don't go away when we put them into landfills or they get dropped into the environment. They just get broken down into smaller and smaller pieces. And the question really is, what happens to them in the environment? Do they get through our waterways, our soil, into our air? So we formed a team with Dr. Megan Brown, Dr. Chitwitty Oo, and we were all really interested in different aspects of these microplastics.
We are looking at microplastics in the environment as a whole, and in particular, the terrestrial and freshwater environment. There's been a lot of research done already in the marine environment, meaning the oceans, but we're really focused on freshwater, like creeks and rivers and lakes, and then also groundwater.
In 2022, the researcher already found microplastic in our blood system, and they also found microplastic in our brain. So that's why the researcher wanted to know about the effect of microplastic in our human health.
My students have been working on Kilbuck Creek. It starts near Malta and then flows north all the way to Rockford. We've been doing both surface water, and then we have these monitoring wells that we've also been able to sample.
So after we collect the sample, we just bring back to our lab, and then we want to detect only microplastic. We don't want other particles. So our LDIR can tell us the identification and quantification of microplastic particle from our sample.
It's a laser direct infrared imaging system. So it uses spectroscopy to actually scan our samples, find all the particles that are in the sample, and then it goes one by one and uses an infrared laser to actually identify what those particles are.
There's very few pieces of this equipment, the LDIR, in the United States. So we've actually started getting clients from like the University of Arizona, Toronto, some other places to do samples for them.
By advancing our analytical techniques, we get a better understanding of how the microplastic particles affect our human life and also our natural ecosystem.
One of the things that we're starting to do is do a lot more science inside of Southeast Asia. We're looking at groundwater resources outside of Sarawak right now. My graduate student Om is looking outside of Bangkok. We're working in Cambodia along the Mekong River. We have a researcher coming in from Vietnam in the fall who's going to help us talk about what's going on into that Delta region of Vietnam.
Students are definitely a backbone. There's so much to do. There's a lot of steps and it takes time. So having multiple people working on these projects really helps.
So we've been training other people in other countries, other laboratories in our methods so that we can become the standard bearers for microplastics in the environment.
We want to show our result to the community, and then we want to make the sustainable solution for our environment. So how do we reduce, reuse the plastic?
So what I always tell my students is that I hope that they can come up with the solutions. A lot of times my lectures are very depressing because it's all these stories about contamination and pollution and everything. And I'm like, but you guys can solve this. I'm hoping that by you all hearing these stories and understanding the issues, you will come up with the solutions. So my hope really comes from all of our students and what they are going to be able to accomplish into the future.